Hello, my name is Dean Peterson. I'm here today to help you run applications on Openshift. Now, one of my biggest pet peeves is when I see a lot of different examples just kind of glossing over a lot of nitty-gritty details, or maybe they're a little bit more contrived. I guess it's not really a pet peeve, but I think there should be more videos that kind of show more in depth what would happen in a real world example on trying to convert an application into an Openshift application, and how to get things up and running and kind of deal with the issues as they come along in an actual scenario. So the scenario that we'll be working with today is taking an application, one of my applications, called Abecorn. It's a math trading application. We can get into that later. It's running on Amazon ECS currently, and we're going to take that and move it onto Openshift. This is going to be a multi-video tutorial. We're not going to be able to fit everything into just one long sitting. We are going to be covering a few topics. So where and how to build containers and images, and where to put them and how to access them. So each one of these things, just those two things alone, there's a lot of different ways that you can go about doing something like that. But we are going to make sure that we pull back the curtain and don't leave anything to being perceived as kind of black magic. I think it's useful to get some of the lower level understandings of what's going on under the covers before progressing on to more sophisticated mechanisms that Openshift can provide. One of those, so Jenkins Pipelines, Tecton Pipelines, CI/CD, like I said, is built in a number of different ways, but the flexibility and the choice is yours. So let's start with something that I think will really make sense, and that way, with that one step prior knowledge, some of the other more elegant solutions will be that much easier to take advantage of later on. Now, that being said, that we're kind of going to go back to some, not necessarily basics, but lower level understandings to make our foundation stronger. I'm going to be discussing and using terminology like routes and pods, so that level of information assumes an intermediate level of understanding, maybe not necessarily of Openshift, but of containers. And then, a basic level of Openshift is kind of assumed for these videos. So if you don't have that level of understanding at this point, maybe some other basic, what is Openshift, what are the various components, would be more appropriate, and then come back to this video. We're working toward getting an actual application up and running in a production environment, the bare minimum that's required for that. And we're going to be discussing some topics that come up when you're moving toward production that maybe get missed in other types of tutorials. So some of those are how to set up SSL certificates and then apply those to custom routes that you've created for your domains. Let's say you have a particular URL, a custom domain that you want to apply to your routes, and then have the appropriate SSL certificate attached to those routes. We're going to be covering that. And then how to deploy your container. Again, there's a lot of different ways you can deploy containers inside Openshift, and a lot of talk is being created around some of the newer modes of deploying very complex workloads. Operators are something that you can use to deploy really complex workloads, and there's an SDK around here. We're going to be sticking to the again, the basics, kind of getting down to that lower level of what is a deployment config, what does that consist of, and then how can I use that to take just a container. I want to take a container, I've got a deployment config, what are all the pieces, let me see really clearly and plainly what are the pieces that I need to take that container and get it up and running inside Openshift. And, I think this will be eye-opening and will help you kind of build those stepping stones to being able to take advantage. Again, like CI/CD has all of these other nice features, deployments and, workloads can be, very complex workloads can be created using some of the newer technology that's coming in Openshift 4, like operators. But let's understand the underlying technology first and build towards those. And we'll have videos on those subjects later on. And we'll be doing some customizations to Wildfly instance. Not everyone can run the latest version of something like JBoss EAP or Wildfly. A lot of times you've made some customizations and you're not ready to upgrade or move to the next version or take advantage of something that was just pre-canned and built into Openshift as an operator. So we're going to be creating a more custom implementation, or not implementation, but a Docker container image that has applied a number of different layers to build up the services that take advantage of an older version of Wildfly that requires an older version of Keycloak and some modifications to the standalone.xml. And so we'll be going into some depth on how to create a custom Docker image, build up those layers, and and take it from there. There will be a lot of key information that just gets uncovered, and you'll not have to kind of spend, hopefully, not necessarily hours, but maybe hours kind of scratching your head on stuff that, hey, wait, where was this in the document? How do I get past this problem? So there's going to be, I think, a number of those moments, and those will get uncovered as we go along, and I think be very, very useful too. Without further ado, let's get started. The first thing that I want to show is what we're going to be moving. Up on the screen, I have the ECS cluster that I'm currently using to run 8 services backed by 8 tasks. And the services here are a number of client-side applications. So this is a client-side app, and a few back-end services that are being run on what you could consider as JBoss EAP. They're using Wildfly, which is the upstream version of that. And when we convert and move over to Openshift, I'll actually be breaking down some of the pieces of this REST services to create it, kind of do that transition more toward a microservice type application rather than putting everything kind of in a more monolithic back end. So we'll get to see what steps you can take to kind of move in that direction if you're kind of doing that transition yourself from a monolithic application to something that's more microservice based. I thought it would be better if I stay down here in the far lower corner and not take up so much space for the rest of the tutorials. The first thing that we will be moving over is this trade service API EC2 service. And that consists of the following modules. This is my development studio, so Red Hat Developer Studio. And you can see the projects that that trade service is going to consist of. Each one of these actually, for the most part, could be broken up and put into its own container and run separate. Right now, and that's what we're going to do. We're going to break out this trade Kafka consumers and this trade processor into their own containers, and then but let's look at now the Docker file that is used because ECS uses containers, and containers are portable. So for the most part, the work is done for these Docker files, but it will be useful to look at what those Docker files look like. And one of the important things when using Docker is you want to make sure that you build upon layers and then only execute inside this, inside the the final command. So you can see here we're building off of this previous. There's a Docker file associated with this image. So this is our base image, and then there's a Docker file associated with that. So anything that's reusable, I'm putting inside steps that happened previously inside other containers, and I'm using those to build upon. So what's happening in this file is just pulling in the code that changes the most for the thing that I'm going to be running. And in that case, it's this trade RS project. So all of the code that gets modified in this trade RS, that gets changed the most. So that's what this Docker file does, is it just pulls in the latest code for that, essentially builds it using a Maven clean install. And then finally, when the container runs, starts up, it's going to call the JBoss EAP, or in this case, Wildfly, its standalone.sh to start the server, and then run the code that we pull in and move into the deployments folder. Now let's take a look at this. Let's work our way backward and look at, because this is a custom, and a lot of times you want to have that capability to create a custom image that you have control over what the Docker files consist of. So let's take a look at, and let's work our way back, this trade service builder image and what its Docker file looks like. So again, this is a Docker file, and these are Git repositories that contain these Docker files. A lot more work is being done in this layer, and it's taking a lot of the other projects that this backend consists of. Right now it's more monolithic, so it's taking a lot of these components that the trade service is right now dependent upon, but can easily, because they're stateless, be moved into their own containers and run separate. So right now they're all kind of being built together in this layer, and then above here we're setting up some of the permissions that are required to kind of pull from the Git repositories for each one of those projects. And so we only need to do that in this layer, and then the subsequent layers can take advantage of what was done previously. So we won't have to do that. You see here, there's other things besides the Docker file. There's some M2 dependent. So this has some dependencies inside there. The dependencies that I needed to pull in because they weren't necessarily the way that. They're not in like a Maven public repository. You might have, a JFrog artifact or what have you, but I just, for the most part, was using public repositories. But for some of these Keycloak adapters, I needed to put them into the Docker file, and then have the Docker file itself add those into the image dynamically. And it knows where they are because they're in the same repository along with the code. Same with this ID RSA. These I mentioned that earlier, and they're in the repository. They're added to the image, and then that way they can be used in the Docker file commands. As you can see, we're not done yet looking and going through all of the base images in its entirety. There is a trade service base image. I'm not going to show you that Docker file. It's right here, and you can see some of the other files that are in there. I'll just tell you what it does, because it's setting up some environment variables with passwords. And again, you probably wouldn't want to do that in production, but we're not going for perfection here. You could use a config map, in actual production, but it does get the job done. So I'm not going to show you that Docker file because it would kind of unveil some stuff that I don't want to show. But long story short, it is making some reusable changes to the Wildfly instance itself. I'm using Keycloak, and I'm making some changes to standalone.xml to configure Keycloak, and then set some environment variable information. And then if we were to look at that Docker file, you'd see that it is also using a custom base image, and its custom base image is finally Wildfly JDK 8. So we can take a look at that Docker file, and then its base is just simply a rel image. So it's just using rel as its base. And so let me just take a look here, make sure there's no passwords. So that's, yeah, no passwords in here, so we're fine. And you could do the same thing, right? You could, what's it doing here? It's just going out and pulling in a Wildfly version, so it's downloading it, given that version. So I'm using here, it's a fairly old version now, 10.0.0.final, right? If you can't upgrade for whatever reason, this is what you can do. You can create a custom Docker image and then kind of build it up into the state that you want it to be in, and then go ahead and run it. It's not too terribly difficult. All right, so what do? We've got all of our layers of Docker images, and how do we build this and get it running? Let's continue on to the next steps. The next step is to build the image. So I've logged into an instance of rel here. You can see we're working on a Windows machine, but for the next steps we need a Linux environment. So I've logged into a remote Linux instance, and this instance, we do an ls. I've pulled down those Git repositories that have those Docker files, and I put them into, so there's a folder called GitLab here. I'll go into that. Let's take a look at what we're going to build, and if you don't already have the images that you're, for in our case, we want to build the trade service. So what we would do, let's say we make a change to, well, before that, let's say we didn't have Wildfly JDK 8, right? So we've got to build that first. That's what we would have to do. We'd have to build each image up. So we're going to go into CD, so Wildfly JDK 8. Now this is already on the machine that we're building, using to build, but let's say it wasn't. I'm actually, instead of, if you are already familiar with building Docker images, now version 4 moved, instead of using Docker commands directly, it's better to use Podman, and that is an environment that will allow you to run pretty much the same commands that Docker allow you to run. It's just what the open source community is moving toward is this kind of daemonless cryo run, container runtime, and then there are other tools around that runtime. One of those to run really essentially Docker commands is called Podman. And Podman in this case, because we are going to push to our images to an Openshift registry, and Openshift registries by default are secured with self-signed certificates, using SSL. You'll need to add on to that this ignore TLS and then allow all certificates, and Docker doesn't let you do that. So you'll want to actually install Podman. You can do that just by doing yum install Podman. So once that's there, you can use Podman the way that, just basically replace Docker in the command with Podman. So let's build the Wildfly JDK 8 image. And we would say Podman build -t Wildfly JDK 8 dot, and then we could go ahead and build that. And the reason that it didn't execute is I have it set up so that you have to do that with a sudo. So sudo, let's go up one, do Control A, and then do sudo. So most of these layers are being performed pretty quickly, and then it's done. and then you have that base image that you can use in the next build. But again, when you look at what we're using here, so if the image isn't there, so let's look at that. So Wildfly JDK 8, it's using rel. It will pull in the rel image locally before it starts its build process, and then we would want to push that, because the next step, if you look at this Docker file, well, we can't look at the next one, base, but let's look at this builder, and you'll see that it's using the base. But what is this here? So that's an actual location. So I'm doing some kind of redundant storage of containers, and I like to do that. I'm actually taking advantage of Amazon's Elastic Container Registry, so that I'm actually pulling from that location. And if the images aren't on the box to do the build locally, so let's say I was calling the trade service base. Now let's do the same thing that we did for Wildfly JDK 8. Let's go in and take a look at this trade service base. So cd trade base, and then we do sudo podman build. Actually, hold on here. Trade service base dash dot. So we'll build that. And again, a lot of these images are already built and they're on the machine locally, and Docker's smart enough to know, as you probably know, that, I can go and get that layer from the cache. So it's already in the cache. A build for these images could take longer, typically, but if the layers are already there, Docker will use the cache to do that. But my point of showing you that is, now let's say you have this stored here, but this isn't something, you need to push this out into the registry that this tag is associated with. So I want to show you that now. And again, it's a little bit different, and it's a little bit redundant, but I like to have and take advantage of ECR because I've got that extra level of security of having my container images stored in multiple locations, because they are going to get pushed to your internal Openshift registry too, and you could use that as the location, and they're going to be there. But then for my Docker images, I like to have kind of like the source of truth for those things be Elastic Container Registry. So let's actually show you how to push to that location. So let's bring up ECR, which is Elastic Container Registry, inside the Amazon console, AWS console. And we're going here to look at the repositories and get the associated, so each one of these repositories here are corresponding with their, the Docker container layers that we were looking at earlier. Here's the trade service builder repository. Actually, we want the trade service base. And then you can go and look at the push commands. The first thing to do is log in to AWS at the command line. Come on, don't be picky. Oh, I have to, again, sudo that. All right, so I'm logged in, and it's using, so I've already configured my AWS credentials in a .aws file on this machine, so you'll want to do that. Put your AWS credentials that will work for the AWS API. And then you can, so if you've built your, right, it's telling you, we replaced Docker with Podman, so we built that image, and then we can tag the image. So we tag the image, and again, I have to use sudo for that. And I can't use Docker. I have to use Podman. So again, here you would want to replace Docker with Podman. And then go ahead and push. So sudo, and then I will have to replace Podman, replace Docker with Podman. Control A. And then it will push. And it'll take some time to push that image, but then you'll have that, that trade service base inside ECR, and then you'll be able to refer to it as a base image using that tag that's associated with your Elastic Container Registry image that's been stored in your Docker file. So while we wait for that, let me explain a few more things. You will need to do that for each one of the layers. So if we look at, let's pull up the GitLab repository, and we do an ls there, and you'll see we've got we've got the trade service, we've got the trade service base, and the trade service builder, and the Wildfly JDK 8. So we'll need to do that for each one of these layers, so that when we finally do build the trade service layer, all of those images are inside the and available on the machine, but really also pushed to the Elastic Container Registry too. Right. So if we look at our Git repository and what we do there, let me just show. It's a little slow because I'm on a VPN network. And so let's go down to the Docker project. Openshift Docker. So in here we have the trade service builder and all of these different repositories, and that's what we're doing, and that's what we pulled on this machine here. So I did a git clone, for instance. Let's take a look at the trade service, or no wait, let's go back and look at the Wildfly JDK 8, the one that we built already. So I did that. I say git clone. So I did a git clone, and then I right into that repository, and that's why we've got that Wildfly JDK 8. Control U. That's, right, that location with the Docker file is a Git repository. And then, anytime you do make a change, you'll notice at the top what I have here is this cache bust. If you do make a change and you want to make sure that change takes effect and the cache doesn't, the Docker cache doesn't kind of get in the way, you can force all of these later commands to be executed by making a change up here, and then it will know that, oh, I shouldn't use the cache, hence the name cache bust, and then build a new image based off of it, off of the new commands. All right. So again, let me kind of repeat that in case it wasn't clear, right? So we need to have all of these images and build them up and push them into the Elastic Container Registry. So they're all, let's say they're all in there now. And we're talking about this location. I'll go back to repositories. So we did all of those same steps. Maybe let's do one more so that it becomes kind of a little bit better, and we have the clarity that we need. So let's go. The next thing after trade service base would be, right, so we've got what we're still pushing here is the trade service base. So we need to also have done that to the trade service builder, but you can't really do that until this one is completely done. So let's just wait a little bit longer for that. It's done now, and what we're going to kind of show is, right, the next step, trade service builder. So we would go into the already cloned, if it's not there, we would clone that Git repository, go to trade service builder, and then we would do sudo podman build-t trade service builder dot and hit enter. And I'm not going to do that. I actually have it already running kind of in the background, and it's doing a large amount of work to build, kind of create this layer. So I've actually had that running in the background already. And then once that's done, we're going to, like we did with the trade service base and the Wildfly JDK 8, we're going to push that into the container registry. But ultimately we want to get this image into Openshift's registry. So Openshift has an internal registry. So even though we're using container, ECR kind of as the source of truth for the container images, to run those images inside Openshift, we need to get them into Openshift and its registry. So let's do that. And one of the things that you do when you create and install your Openshift environment is you create an installation directory. And that installation directory is on this machine. I'm going to go into OCP. So if I do an ls, I've got an install.dir. If I do an ls-a, what we're trying to get access to is this, right? Here's the OpenShift console. But if you didn't know your OpenShift console's URL and then your initial kube admin username and password, you would find that in your OpenShift install log. So OpenShift_install.log. I like to save off this environment, this installation directory with all of its information, and put that into a Git repository too, so that I have it just in case anything were to happen to this machine. So I've already got that location, and I've put it into the browser up here. We need to log in. So I'm using kube admin, and I need to get the password. So I'm going to kind of pause here, get the password, come back. I won't show you guys the password. And again, this password is the password that I retrieved from that OpenShift install log file. Once we're there, what we're really after is the command line token that we can use to log in to this location. And these tokens expire after a certain amount of time. So by the time you see this video, this token will be expired, and you wouldn't be able to use it for logging into this location. So we would come back here. Okay. And then OC get nodes, just to kind of make sure that everything's working correctly. And I've reduced the number of nodes that I'm using for this tutorial. You would typically want to have 3 masters and at least 3 masters and 3 worker nodes running. I've just got 1 master and 1 worker node running. And then OC project, make sure. So we're just on the default project. And Now what we need to do is log in to our Openshift container registry. And I'm going to look at my history because I have it in there. And there is a useful setting if you look at a host. So I'm going to execute this guy here to make sure that I have the URL set for my Openshift image registry. And what I did, now if you look at that host command, so I'll remember that 840. But it's using, the registry is installed in this Openshift image registry namespace. And you can see your namespaces here. So Openshift image registry. If we went in there, we could see our image registry, and then there would be pods associated with these deployments. But what we're trying to do is, and by default, it's not actually exposed externally, but I find it, nice to have the ability on a machine like this, or any machine, be able to log into that registry and push images that I might have built on a remote machine and push those into the registry. There's quite a few ways to do this, but we're trying to make sure that there's no black magic here. So this is really what some of the build configs and other mechanisms that are available in Openshift will do, kind of without you being seeing what's going on. But let's have complete control over our process right now and show kind of how you get an image into that registry, and just kind of do it manually. And to kind of help facilitate that, I've exposed my Openshift registry through a route. So if I do, let's say we go to that namespace. So let's go to this Openshift image registry namespace. So OC project Openshift image registry. And then let's look at the routes. I created a route. Let's see, get routes. And one of the nice things about installing on AWS using the API installer, when you first start the process, if you're using and you've got your domains inside Route 53, it detects that, oh, hey, here are your hosts, your hosted zones and your domains that are available, and you can just pick from one of them. And then when you install OpenShift, and by default your routes that you will create then inside, so how things get routed, this isn't necessarily, how do all of the things like routes and everything work in OpenShift. Hopefully you come with some of that information, but just kind of as a refresher, right? You create a route. That route exposes your service. You're not actually going through the service layer. You're going right directly to an IP address that's associated with the pod. So you're actually exposing those containers to the outside world, and then OpenShift knows how to route to those containers. And I've done that with my registry running in the OpenShift image registry namespace. And then because I installed using API, it takes one of my domains. So I used enterprisewebservice.com that I own, and then it applies this subdomain to this enterprisewebservice.com domain, and then I can actually use that in calls to find my way to that container. And I'll be using this, and that's what this one command. So if I do pound 840, I'm setting this host variable so that if I did an echo $host, it will reveal that route to my registry. Then I can do a login using Podman to the OpenShift registry, and then I can tag my images appropriately and then push to the OpenShift registry. but there's some information that you'll need to know before you push to that, so that it you get it to the right namespace, and it's associated with something we referred to as an image stream. You can think of an image stream in OpenShift as the same thing basically as an image, and that's how your projects will, right? It has to reference an image stream to take that container and run it, and we'll go into all of that. But right now, let's show this push of a container into the so first let's log in using Podman, and then this route to the registry. So if I do history again, since I've done this previously, I want to look for Podman login, and then this OC who am I -T will grab that token dynamically, so I don't have to remember it. And then here's where Podman is really kind of a necessity, because Docker doesn't allow it. So the registry is secured using SSL, but it's a self-signed certificate by default, and so we'll want to not do verification of that SSL certificate, and you can't add this TLS, at least on the version of Docker that I've got installed on the machine. Podman though does support this TLS verify command, and that's pretty handy. So I'm gonna then execute this 841 command that I have in my history. So pound 841. And now I'm logged in, just like we had to log in to push to the Amazon container registry, where we had, so if we go back here and we look at any one of these, so let's say we took a look at this and look at the push command, it's kind of similar here, right? We're logging into Amazon, but instead of logging into AWS, we have logged into the container registry that is installed with the installation of Openshift. Let's keep moving along here. Our trade service builder image has been successfully built. So the last thing that we executed in this command prompt was sudo podman build -t trade service builder. The next thing that we have to do is push that to the container registry, the Amazon container registry. Right, so again, we'll go back and look at our repositories, get the push commands. We don't have to log in again since we're already logged in. We did the build. We're going to do the tag now. We're going to copy that. And we have to use Podman instead of Docker. So we're going to go back to the beginning of the command. Podman. And finally, push that to the container registry. And a lot of those layers already exist inside the container registry. But then we're not going to do all of the layers because they actually are there. So if we look at this, so they are there. I've built them previously. I just wanted to show you enough so that you would use the same process for each one of the layers until you finally get to the top layer and you have your final image. And your final image is the thing that you're going to push into Openshift's container registry. And that final image, again, is the trade service image. So you've got your final image. So in this case, just kind of want to go back in, right? This final image is the thing that is going to run this command that's going to start up your server. So what do we do to get it into? So we've already logged in using Podman to the container registry. And we're going to then create a namespace. So the next step is, where do we want that to go? So we've logged into our Openshift console. Let's look at our projects. So I'm going to create a project called Trade Services Core. So Trade Services Core. So I'm going to create that project. And then, so I am already logged in. So OC project. Let's switch to that project at the OC command prompt. So Trade Services Core. And now that we're using that project, we have to create an image stream of the final image. So again, let's imagine we've gone through each one of those layers. We finally built up our final image. We push that into the Elastic Container Registry, and now we're ready to push it into our OpenShift registry. The first thing that we want to do is create an image stream inside the namespace that we're going to push and associate that image with. So I'm going to say OC create image stream, so IS, and I'm going to call that image the same name, so trade service. So we've created an image stream called trade service. One of the things that's useful, so let's say OC, not OC, so we're going to do sudo podman images. And take a look at the images that we already have on this machine that we can push to the container registry. The podman images command is showing that we have the following images on the local machine that we are going to, we're going to need to push this localhost trade service. That's that final image that we need inside the registry. And you'll see some other tagged versions of it here. So what we're going to do, we have to have, so once we created that image, so we created that image stream, right? So OC create image stream inside the trade core. So we've got the trade services core project. We need to tag the image like we tagged, and I've deleted those other, so we're pretty much starting from scratch. I've deleted these other projects that I had things set up in. We're going to have to do something similar, tag it similarly, so that it matches the namespace and the name of the image stream that we created. So let's look at our history to get the right command. So if we take a look at, we'll be looking for a podman tag. So let's grab 847. Now we're not going to use the Kafka consumers one, but let's just post that and change it to, so trade service, because it needs to match the name of the image stream that we created. And then we have to use the right namespace. So we're going to be doing trade services core. And then the actual local image that we're tagging is trade service. So localhost trade service. So we're tagging that local image with a tag that's going to match what we need it to match so that our image stream can associate itself correctly with the, eventually, so we're going to use this tag to push, and when we push, the tag has to match the namespace so it knows where to push to. So we've got the route of the registry, but then we've got the namespace that we're pushing into, and then the name of the image stream. So that's what the tag is going to look like. So once we tag it, and then we're going to push. We're going to push that image. So let's go back and look for the push command. So we're going to copy something similar to this. Again, we're going to use that TLS verify equal to false. And it has to be, we need to push the right image. So let's again do what we just tagged. So trade service, and it has to match the namespace. And the namespace that we created is trade services core. Let me close some of this stuff down. Services core. Let's make sure everything's right here. So sudo podman push default the route to the registry, the namespace, and then the image stream name that we gave the image stream. And TLS verify false. So we can go ahead and push that. And when that is done, in our namespace, you will see under builds, we already have an image stream there, but we don't, and we do actually have a tagged image. And the reason that it's there is because I've previously pushed that that image, so so it knew how to find the trade service latest. But that's what we're doing. We've now pushed the image into the registry, and inside the console, you can find that image stream, and then you can see the appropriate image stream tag, which is associated correctly. All right, now this is available to be used in a deployed application. So the next step is, how do we deploy an application and use this container image? I have another Git repository, and that Git repository contains Openshift templates. And Openshift templates can be used to, when you upload them, define objects within Openshift. So objects are very important, and most of the objects are, a lot of the objects are native to Kubernetes, but there are OpenShift specific objects that you'll want to create, namely deployment configs and such. And then with OpenShift 4 and operators, you can create custom types of objects, but that's not something that we want to talk about now. What we do want to talk about are the objects that are needed to deploy that container. The container that we just uploaded into our registry. I have a template under OCP4 here It's the trade service template. And this used to consist of it used to consist of a build config as well as a deployment config. So you'll see under here, this is a template, and it has objects. It has an array of objects. I define a service. And if you are familiar with something like ECS, something has to map that container to port numbers on a particular instance. Now, in the case of Openshift and Kubernetes, everything is very elegant and nice, and you don't have to do a lot of work to map that type of thing. Now, what I found in ECS is I was using an EC2 instance in the background, and there wasn't as nice of a overlay network, so I had to more manually kind of increase a container is listening on a specific port, and then if I was going to run more than one instance of that particular thing, or even a different type of service, I had to change the port numbers. One of the nice things with Openshift is you don't have to worry about any of that stuff. You can, if let's say you want to create a definition of a service that's going to use your container, and you want it to listen on this port, you could define every single one of your services to listen on port 5432. It wouldn't matter what machine it's on. An overlay network takes care of allowing you to overload these ports like that, and then you will be able to then just have like a standard, like if your route was using the standard 80 port, right, the HTTP 80, then it would say, all right, I'm going to go through 80, and then the route will take you into the container, and then the container will be listening on port 5432, but you could have any number of services and containers listening on port 5432. So that's nice, and that's what you're defining inside your template here. And so I do have, there's a lot of things that are predefined inside Openshift, so you don't have to get down to this level. But if you are creating something custom like we're creating, you're going to want to get familiar with how to create templates. And in this template, the majority of the work, and you can even create a build config, but the majority of the work is a deployment config. And the deployment config is taking advantage of this service that we define, and you're setting the port numbers, really just kind of defining the port numbers. But then you want to, right, at some point you have to make a reference to that image, and we do that in this location. And we define triggers, so when we change the image or a new image gets pushed to the internal registry, this will trigger a new deployment, and Openshift will take care of that deployment for you without having to turn your service off temporarily, so there will be no outage of your service. Down here we have a very important part, and that's the definition of the containers that you're going to be creating themselves. Here again, you're going to be referencing the image that, so it has to match that image stream name. You give it a name, and then you reference that target port for the container and what protocol to use. Now this is a little bit more, I wouldn't say complicated, but we're creating a stateful container. And one of the things that I'm using so I use an Elasticsearch or I use Hibernate Search, and then it uses leucine indexes, and I store those leucine indexes in the file system. And I don't want those indexes to go away when the containers go away. A container should be a bit more ephemeral, and then they can come and go, or you can scale them up as you please, but they should all be able to share the same persistent volume store that can reference these leucine indexes. And you can define in your template what your container should, what paths should be persistent and what persistent volume should be associated with that. So here we've got a volume mount. We give it a name. This is our path to the indexes, and then we create some volumes And then these volumes, and I can I can show you a little bit later that you have to define a persistent volume that then is consumed by a persistent volume claim, and we make reference to that persistent volume claim here, so that this path will be stateful. So there's not a lot to it. Once you get the hang of creating a deployment config, right, or you can just get an example deployment config and then just modify that, it's not that difficult. And for the most part, you're defining what port numbers your container should use, if there's any persistent volume stores, persistent paths, and then give your service a name, and then what your container, what image your container should use, and that's pretty much it. So let's go ahead and use this deployment config now. And you do that, so let's make sure we're still in the right project. We are, and then we need to get into the right directory. So as I mentioned, that's a Git repository, and I've cloned that Openshift templates repository. So there it is, Openshift templates. So CD right here, CD Openshift templates, and ls. We're going to go into OCP4, and we're going to do OC create -f. -f stands for file, and we're going to now so actually we're not going to just create it, we're going to have to process that template. And so creating it would just create the template, and it would be something that was within OpenShift, and in the past when it was a service catalog, so we're going to instead process the template right away and trigger a deployment config, and then create the actual running service. So I'm going to do history again because I've done it already, and I'm going to look for that. So here it is. So OC process -f OC create. So we're going to run this command, and that will take everything that's inside the template and start creating it. So let's go and see, as it's being created, what's going on. So now let's go to status. So you'll see here now we've got a trade service. Let's see what the error is. So there's an error. There's no call for alarm. We'll figure out what the error is. There's going to be an event somewhere. Let's see. Oh, the persistent volume claim is not found. So we need to create that persistent volume claim first. And how we can do that, I have templates already created for those. So you can kind of separate your templates the way that you want them to be separated. And you could put all of everything into, right, I could have put the persistent volume claim definitions and right inside the previous template that we just processed, but I have them separated out. So let's do ls again and look for actually the first thing. So I don't actually have a template for the persistent volume claim because it's not that difficult to create. So we're going to go into storage, and first let's look at our storage classes. What's great about running the IPI installer is by default you get a persistent storage class set up for you, and that is AWS EBS. So AWS EBS is elastic block storage, and that then you can just pull from the cloud elastic block storage that you can use for your persistent volume claims. So let's create a persistent volume claim and give it a name, and the name that we're going to give it is the name that we gave to the deployment config. So what name did we call that? We called that Lucene Indexes PVC. So let's copy that, Go ahead and paste. It's going to be shared access because we want a lot of different containers and potentially services to be able to access that. So you could have it just be single user or shared access. We're going to do shared access. And then we're going to make that of size, let's say, let's just say 9 gigabytes. And we can create that. So it's pending. So persistent volume claim can only be created once it has a persistent volume, and the persistent volume is the actual storage itself. So you make a claim on that storage. And I don't yet have that, but I do have a template for the persistent volume. Okay, here it is. It's under the file Lucene persistent volume. It is of kind persistent volume, and you give it a name. You can give it some labels and then specify its capacity. And I'm just matching, it can be much larger than your persistent volume claim, but then it's going to have a volume ID, and this volume ID is an actual volume inside Amazon. And again, your storage could be a lot of different things, but by default, what's set up for you nicely is using elastic block storage. You could use Ceph, Gluster. You have a lot of different choices, just like Openshift is flexible. And even your container registry, one of the things I mentioned, I like Elastic Container Registry to be the source of truth. And then I've got that redundancy with the internal registry of Openshift. Well, you could make the internal registry of Openshift actually be the Elastic Container Registry if you wanted. All right, so let's go to Amazon and then look at our EBS volumes. So I'm going to go to EC2. And go to the volumes. And I've named one Elastic, so Lucene indexes. And it's of size 10 gigabytes. And it's available. So this is the one that we're going to use. And we're going to use this volume ID inside the template for the persistent volume. And that is the correct volume ID. We're going to set it to read write many. And then we're also going to, we can make a claim reference to our persistent volume claim in here. It's a little backwards, but it helps make the binding happen. And we're going to say, we're going to give it the right namespace. So we're going to name it the right namespace. Trade Services Core. Let's change this to Trade Services Core. And then we're referencing that persistent volume claim. And we're going to make sure that when let's say there weren't any containers running that were using this persistent, you could make it so that this persistent volume and persistent volume claim goes away, but I don't want that to happen, so I'm setting that to retain, so that if there aren't any containers, this state and this data will remain. Okay, and then you can set some node affinity if you choose. Now we do the same thing. We're going to process this template. Now I do have to upload the changes that I just made for the namespace. So I'm going to go over here to my local machine. So I need to do a change on my local machine here. Namespace change. We're going to go back to our remote machine, do a git pull. Oh, I went back to my local machine there. Let's go to the remote machine. All right, git pull. Gmail.com. Okay, so let's process that template too. History. I've done that in the past, so let's find the right process. So in here, we're not actually going to process it. Actually, we can just create. We can just say OC create the persistent volume. So let's do that. Already exists. Oh. It exists in a different namespace. OC get PV. All right, let's say OC delete PV leucine. And right now, that persistent volume doesn't have the right reference to the right right namespace. So we're going to do PV dash PV. There. Now we can go ahead and create that. And then we should see this get triggered. And now it's bound. And then that should go ahead and kick off. If we look at, and if it doesn't, we can go ahead and then kick off, start the rollout again. All right. So now we've got 2 of 2 pods. We can drill down. Let's go back actually. So we've got our deployment config. And we're going to go to our resources, and we've defined our trade service. And now we can drill down to the pods. And then, so I know what that error is actually. And because one of the things that we did, so we can go in and look at the logs, and we get a permission denied. Now, if you go back and look at what I did inside my Docker container, or my Docker file, so down here, I'm running as user root. Openshift is very secure and doesn't usually like you to do that. For expedience sake, with this custom container, you have the ability, and one of the nice things that you have with Openshift is you have access to the control plane and being able to modify things as you wish. We can allow our containers to run as user root. So that's what we'll need to do. And I have a command for that I've already done. And we're going to be looking for OC ADM, which is OC admin. Right here. And we're going to add to the admin policy the ability to run as any user ID. So allow our containers to run as root. So we've added any UID added to our trade services core namespace. All right, let's go back and redeploy. So we're going to go back to status. We're going to action. So start the rollout again. It will increment the deployment config to a new number, and it'll keep track. So if we drill down now and go to resources, our trade service, go to our pods, and that's looking better. So the container is still creating. We can watch the log as they get created. So here you can see Wildfly starting up. And once it's started, we still need a way to get to our service. How do we use it inside our application? So I've got some client-side applications that are calling REST services that should be referencing this container. And we've got, as you saw, we've got 2 pods. So one of the things that I did inside the deployment config, so inside Openshift templates, inside the Openshift templates here, I set the replica number of replicas to 2. I could spin this up to any number that I wanted as long as I don't go past. So if I go to status, go to all projects. So right now my memory usage is at 75%. And the reason it's at 75% is I actually, and I'll be showing it in a later video, I'm running a Kafka cluster on here too using an operator. And so that'll come in a later video. But Wildfly, you can think of as JBus EAP, is using very little memory right now to run. And I'm going to go back to the container or the namespace. So this trade services core namespace. Let's go and look at how our service is doing. Pods. So they're running now. You can look at all of the stuff that happened. So this is just these are the logs you can take a look at anytime you want. So it's up and running, and both pods are up and running. You can take a look at the other pod log. So both pods are up and running, but we still don't have a way to let our front end get to them yet. So how do we do that? We have to go back and take a look at what gets set up on installation inside Amazon. Namely, let's take a look at Route 53. So I've got some hosted zones here. And the Openshift hosted zone that I set up for Openshift itself. So when we're referencing in here, you see in the URL enterprisewebservice.com. So I've got my Route 53 here, and it sets up some records inside the public section. So if you're trying to get access externally to Openshift, like I am, then you would come through this direction. But let's say you had a container that wanted to reference Enterprise Web Service, and it was inside the VPC, and it was using Amazon's private network. Then it also sets up, so right here, all of your apps and services, it'll set up this public record, and then it's got a wildcard associated with it. And then it makes a reference to a classic load balancer. And so anything coming through with this name, that's a service that you are going to be running containers. So by default, if I said OC expose my service that's running now, so we go back and look at this and what it consists of. Resources, got a trade service. We could expose that, and then by default, if you just said OC expose, it would get, so we can go ahead and do that. Let's go ahead and do that. Say OC project, let's make sure what project we're in. So OC get routes, so no resources found, but OC get services. You can say SVC for short. We've got one service. So we could go ahead and expose that. So OC expose service trade service. Now it's exposed. And by default, everything's set up for you And you can take a look at the route. And now we have a route called enterprisewebservice.com. If we click on that, right, if you just go to the base URL, you're going to get to just the wildfly that's running. So there it is, it's up and running. But I don't want to use the domain that I used for Openshift itself. I want to use abecorn.com. That's a different hosted zone. So how do I set that up? Right? So I've got abecorn.com. And how you do that, so right now the route that I'm particularly interested in is this services.abecorn.com and insecure services.abecorn.com. Those should point to my new running container inside Openshift. Instead, what it's doing is it's pointing to this trade service API load balancer that is being used by ECS to route traffic from the ECS container, so through Route 53 to the ECS container, and I don't want to use that. Instead, I want this to point to my service inside Openshift. So how do I make that happen? The first thing that we need to do is take a look at what was done for the enterprise webservice.com route, right? So everything's going through this load balancer, and this load balancer is set up nicely already for you to use. Let's go take a look at it. So it's this A85494. Let's go take a look at it. EC2. Take a look at our load balancers. It's this guy right here. Now let's take a look at the listeners. So it's set up to listen on 443 and 80. But you'll notice there aren't any SSL certificates at this level. Now when I used for ECS this load balancer, I used an application, load balancer, and I could put, so I had, this load balancer for ECS, its listeners were a lot more, it's kind of convoluted because you had to set up rules and definitions for those rules and then route to a particular target group. You don't have to do any of that with Openshift, which is nice. You can just use a classic load balancer and it sets it up for you. So we can take a look at this guy. Its listeners are very simple. It's just a classic load balancer listening on 443 and 80. But you don't put your SSL certificates there. Unlike here, where I had a 443, and I could use Amazon's automatically generated certificates, and then apply them. You do it differently in Openshift, and I think it's better. You have more control over, not necessarily more control, but you put them in a different location. So you keep your load balancer itself pretty simple. You don't have to modify anything inside Amazon. You don't have to apply the certificate here. But we do want to modify our Route 53 definition for secure services and insecure services under Abecorn to point to the right load balancer. So let's change this to be an A record, and we will use an alias. And the alias we're going to use is that classic load balancer. And save the record. And then we're going to do the same thing for insecure services. We're going to change that to an alias, make that the load balancer that was set up for us. Save the record. And one of the things that's a little bit of a gotcha is you also, let's say inside your container, if you're going to, now you'd most likely instead want to use the service name, so you don't go out to the external public internet. But let's say you wanted to reference anything within your private VP, your VPC that was referencing your anything that you wanted, that you had defined publicly in in your public Route 53 definition. It won't be able to get to it because there's a different DNS system in the private location inside Amazon. So when you install Openshift, you'll see that they create records in public and private, and they kind of mirror each other. So in private, they also have apps.ocp. You need to do the same thing for your particular domain. You have to have a private one, and in my private one, I have insecure services and services. So there should be. Now I don't reference services inside it, but I could do another. So I've got insecure services here. I'm going to create another record. I'm going to call it services. It's going to be an alias. And again, it's that classic load balancer. Create. So now we should be all set up to use, so we should be using the right route now. So again, you won't see necessarily any change. Services dot, oh actually here, so there won't be anything here yet, but services dot abecorn.com, because we haven't defined it yet. So there's no, it doesn't know where we're going, but it does know that it should go to that load balancer, which is pushing everything to Openshift. So this is an Openshift message, but we need to define the route. So say OC get routes. And one of the things that we're going to do is we have to create a secure route. So one of the routes is secure. Again, you can do that with a template. I have a template here. I've removed my actual certificates, private SS, RSA private key, because I'm not going to share that online, but you can generate using Let's Encrypt. So let's say you use Let's Encrypt. I'm not going to go through that process. That's something you can easily look up how to do. So you can create a wild card SSL certificate, and then you'll get the various parts that you'll need. It's pretty obvious because it's kind of all separated. You'll have your RSA private key. You can just drop that whole thing right in there. It'll be a big long block of text. And then you'll get your certificate. You'll do the same thing. You'll paste that in there, and then you'll get your certificate chain. So you can put your CA certificates there, and then once that's created, you can, just like the other things that we ran, you can define your route using a template. So we'll do that. So I'll restore my text that's in here, and we'll run it, and we'll see what that ends up, how that ends up working. So let's do the easy route first. I have that defined here, and I've deleted the old route. We no longer want that long web services URL here. So make sure OC get routes. I'm going to go up one level because I want to run this template. Abe service non-SSL route. It's very simple, that one. Say OC create, like before, Abe service non-SSL route.yaml. That's created, but then we're going to go back into and create the OC create abe service SSL route.yaml. Oh, we still need the -f to define it. Let's do OC get routes now. So we've got insecure services and services. Let's call services.abecorn.com and see if the certificate is valid. Let's just refresh this. So we're going to the non-secure one, but it's working. Let's go to HTTPS, and we have a valid certificate. So certificate valid. At this point, we have a fully functioning Wildfly serving our back-end REST services to our application. And, again, we could, and I do have other projects for some of the other processes, and I'm going to break things up. But right now, we can go to the actual application. I haven't shown that yet. We can go to the application, get started, and we'll see. So let's take a look at what services are being called. Let's take a look at the network. Let's call that again, reload, and at some point we should see our secure service being called somewhere. Let's take a look. Full text. I know that's one. So let's see here. We're calling HTTPS services.abecorn.com, and it's working just fine. We could take a look. So the thing that's being done there. So let's do a full text search. Let's say CFall, or not CFall. Yeah, there we go. There it is. So we know that it is a functioning service running on the back end, being served up by Openshift. Now, if we wanted to, we could easily scale that up to even more pods. So let's do that really quickly, just to show that. So we're going to go to our status. We're going to go to our deployment config. And right now our desired number of pods is 2. Let's bump that up to, let's do 4. Go ahead and save. And let's take a look at our pods. So we've got 2 running and 2 being created. And if we wait, and we didn't have to wait very long, they're up and running. And we can scale that down again if we wanted. Go back to overview. Edit that, bring it back down to 2. And what we should see, so we've got 2 pods running and 2 terminating. All right. And we will continue on this journey of converting the entire application. So there's still quite a bit to go through, but that will give you a really good starting point on how to take your maybe your older, maybe monolithic type workloads and start running them as containers inside Openshift. All right, thank you.